Hey guys, this is chapter 8, section 5, equations, part 2 video. 3 problems left to do. Hopefully you watched the first video. So we left off on number 6. And again, if we did not talk about the fraction exponent thing, you may need to take some time to look that up or come talk to me. But I will tell you this, a fraction exponent means the same thing as a root. So back here on number 5 that we already did, notice the 3 cubed root. So I get a 2, so that means I'm going to have a square root at some point. And again, assume to be a 2 right there. Don't have to write it. But what's being raised to the half power? This one's a little more obvious than number 5. The x minus 2 is being raised to the half power. It's the guy that becomes the root. So roots and fraction exponents mean the same thing. So where was the 3? Where was the 17? Where was the 5? Okay, continue to solve. So if you watched the previous video, you would know that the next step for a square root, cube root, radical problem is to get the root by itself, meaning the 17 and the 3 have to go. Now, it would be tempting to add those two together, but that's 17 plus a 3 that has something attached to it. So I can't combine those two. Now, the other thing you might be thinking is, how do I get rid of the 3? I got to divide by 3. And you'd be right, but not at this point. So normally when we solve an equation, we get rid of pluses and minuses first. So the first guy I'm going to get rid of is that 17. So I get negative 12, 3 square root of x minus 2. Now I can divide by 3. Okay, now here's where it gets weird. I said it in the last video. I'm going to say it again. I don't make up the rules to math. I report them to you. So if you were paying attention, I'm going to scroll back up to the box that we talked about in the first video. There were 2 things that cannot happen when you are doing radical problems. And one of those things is an even root can never equal a negative number. Well, that problem we're working on, that's an even root. So it's a 2 for an even root right here. And at this juncture, I just wrote down an even root set equal to a negative 4. That is impossible. It can't happen. So if you're paying attention, and I understand that's going to be really hard to remember, you're done. You can write no solution. Okay, now if I keep going, see if I can do this in my head. Square both sides, you get 16. Add 2, you would get 18. So likely that somebody might come up with an 18 for an answer. But guess what happens if you were to take that 18 and plug it back in for x and check it? It doesn't work. So you have to do one of 2 things. You either have to remember this detail right here, which is that a negative number can never be set equal to an even root, or you're just going to have to check every single problem. I'd opt for trying to remember that if I were you. All right, so that ends up being fairly easy if you notice that, because, hey, I got a negative 4, I can quit. I don't have to finish the problem. All right, number 7. This guy's going to be tough. Here's why. There are multiple square roots. All right, well, in the box, this is the directions to get the toughest square root by itself. So the x minus 15, a little bit tougher, just the regular old square root of x. He's already on the left side by himself. So now, here's why it's tougher. So you might be thinking, hey, I could just square and square and square, and both those square roots would go away. But here's the problem. You're supposed to do the same thing to both sides. I just got done squaring one side one time and squaring the other side both times. That's impossible. That's illegal. So here's how we go about doing a problem that has multiple square roots in it. Strap yourselves in. You're not going to like this. I can square that side as long as I square that entire side. So good news, that guy would just pop out of there like the other problems. The bad news is the guy on the right becomes a FOIL problem. Because if I'm going to square a set of parentheses, I got to write it twice. All right, here we go. First times first. That's 9. Multiply the outside 2. It's negative 3 times the square root of x. Multiply the inside 2. Same thing. Last one times last one. Well, it's a negative times a negative. And I get a pair of x's. So if I take a square root of a pair of x's, I get 1x. It pops out of there. So kind of like what happened on the left side. Cleanup time. Got my x minus 15. I can put this negative 3x and this negative 3 square root of x together because they are like terms. So negative 3 of something and negative 3 of something will be a total of -6 of those guys, plus x. Well, the goal is eventually to get the x on one side, so I'll have to do that eventually. So those guys cancel out conveniently. Okay, I'm getting a little bit short on space here, so I'm going to do 2 steps at once. Got to move the 9. So I get -24. Left this guy, getting there. Remember this trick. If I don't like the signs the way they are, I can change them just as long as I change them all. Divide by 6. And how do I get rid of a square root? I square it. And I got 16. So you might be saying to yourself, whoo, that was a lot of steps and that was a lot of work and that was definitely not an easy problem. And I'd say you're right. Now you're going to hate it even worse. Go back to the original problem and tell me how many x's you see. I see 1 on the left side. I see 1 on the right side. That's multiple x's. You got an even root problem, which we did, with more than one variable. You got to check it. You don't get a choice. So I'm going to check it over here, way over on the left side. Plug in my 16 in for x. The other side said 3 minus the square root of x. Plug in my 16 in for x. Let's try it. 16 minus 16 minus 15 is 1. The square root of 1 is 1. Square root of 16 is 4. But 3 minus 4 is -1. Oh no! That's called an extraneous solution. We did all the work right. We went to check it, and it doesn't work out. Is that a lot of work to find out that the answer was no solution in the first place? Yep, but how else are you going to get it other than blatantly guessing? And I don't recommend that. All right, number 8. I'm just going to start it off. There is no way I'm going to have time to finish this one. But just to give you the idea. So the giveaway here is there are multiple square roots. There are multiple square roots. You're going to have to do a FOIL problem. So the question is, do you want to do the FOIL problem with those 2 guys? Or would you rather do the FOIL problem with the 2 and 1 of the square roots? So that's what was in the box. It said always get the harder square root by itself. So the y minus 17, a little tougher than the y plus 3. I could pull the sign switching thing here, make that positive, make that negative, make that positive. Now I have less negative signs, but the bad news is going to be this. I can square that one, and he's going to pop out of there. But the guy on the right side, that would have to be a FOIL problem. And it would, in fact, be a nasty FOIL problem, maybe even a little tougher than the last one. So unfortunately, I'm not going to have time to go through all that with you. I will tell you this, though. If you solve this one, and go ahead and try it on your own if you'd like, you should get y equals 33. And the reason I'm bothering to tell you that is this. Original problem was an even root problem. It had more than one y. We would have to check it. So if we do check this one, plug a 33 in, I would have the square root of 33 plus 3 minus the square root of 33 minus 17. And does it equal 2? Sorry about my slop. So 33 plus 3 is 36. What's the square root of 36? It's 6. 33 minus 17 is 16. What's the square root of 16? It's 4. Does 6 minus 4 equal 2? Yes, it does. So y equals 33 would, in fact, be correct. The reason I did that was just to point out to you 2 of the problems I did ended up not checking. Just wanted to make sure you knew that they do actually work occasionally. All right, but very important. Multiple x's in problem number 7, had to go back and check it. Multiple y's in problem number 8, had to go back and check it. Keep in mind, if it's an odd root, so if those guys had been cubed roots or fifth roots, we would not have to check it. But I think you guys know by now, checking is always a good idea. All right, need more help with the FOIL problems? Let me know. Thanks for watching.